All right. Hey guys. So this is our first kind of digital statistics class. We're kind of gonna have to review a little bit of chapter 3, but we're gonna do some interesting stuff here. Well, as interesting as stats gets. So first, some housekeeping. First, it's a new trial thing. It's gonna be a little weird. We're still kind of figuring it out. Let me know what works or doesn't work via either email, Google Classroom. Y'all can reach me however you can, and I'll try my best to be super prompt on that. I'll be varying up some of the recordings too. Some will be just like this, just me talking through a PowerPoint, and then others will be me kind of at a whiteboard, like just drawing things out, like equations and things like that. And then, yeah, sorry if this one is a bit weird. Kind of still getting over a cold, so I probably sound terrible. Um, but yeah, class schedule. I already posted this up on Google Classroom, but I figured I'd just do a reminder. So the quiz for this lecture will be due exactly 1 week from when I upload this recording. So far it's looking like I'm going to be getting it in on uh, Tuesday evening. So I'll probably set the due date for the quiz Tuesday at midnight. So going forwards, next week and going on, I'm going to upload the recordings, materials, and quiz on Monday mornings, and then the quiz will be due midnight on that Friday. You've got as much time as you want to look over the material, to talk about it amongst yourselves, to email me. Yeah, and then it's totally fine if y'all want to take the quiz together, separate, whatever you choose. Just trying to figure this out as we go. All right, so this week we'll be talking about types of data as well as the design of experiments. Next week we'll be getting into the sampling design and research ethics as well. So first let's talk about types of data. The first one is kind of the most useless, anecdotal data. So there's that old saying in science and statistics, the plural of anecdote is not data. That's because an anecdote is just a story or an opinion of individuals and groups. You can kind of think of this as, hey, this one thing happened to my cousin once, or hey, there's this old wives' tale that, you'll get heartburn and it turns out you're gonna have a boy or something like that. It can help us point us to it can help point us towards possible solutions, but it doesn't really provide a basis on itself to making conclusions. And then often anecdotal data can point us in the wrong direction, since anecdotes are by definition unusual and interesting. I mean, I bet you if I had time and just wanted to work hard on it, I could eat exclusively at McDonald's and lose weight. It's totally possible. I can eat under my calorie count and lose weight on McDonald's. That doesn't necessarily mean that McDonald's is a good weight loss strategy. It just means that it worked for one person. But in statistics, we're not talking about one person, we're talking about groups of people. Next, available data. So this is data gathered for another purpose, but that might help us answer our question of interest. It's a good portion of the research being done in America. We also call it secondary data. Think of doing research, doing an experiment as primary data. Well, this is using that data that's already been collected over again. It's secondary use. This is helpful because gathering data can be really expensive. That's why you need things like federal grants, research grants, and stuff like that to be able to do research, because it's really, really expensive. You got to pay research assistants, you got to pay participants, you've got to get space for your lab, etc., etc. Oftentimes, you can use research that's gathered by other researchers. That's usually in grad school. That's how they do it most of the time. Because you don't really, let's say, to get your master's degree. Master's degree is 2 years. You really don't have time between classes and everything else you have to do to be able to design and complete a research study. So most of the time, the professor that you're working under will just give you data that he's already looked at, and then you can do research on that. You can do data analysis and form your own conclusions. But there's also the government. Of course, we pay for the research the government does. So by law, we are allowed to access that research that the government does, whether it be the CDC, Bureau of Labor Statistics, even the census. There's also sample surveys and experiments. So a sample survey is called that because we sample a portion of the population and we ask them questions. We then use that information and assume that it's an accurate sample example of the total population. Well, why do we sample? Well, asking the entire population about, for instance, how they feel about the president is both expensive and very time consuming. You can look at political polling, like, say, look at Quinnipiac University, which is a fun word to say. Quinnipiac University is one of the best political polling. They've been doing it for as long as I've been alive, and they're the best when it comes to political polling. And they only survey like 1,000 people, and they use that to see, okay, this is what how Americans feel about the president right now, throughout the years. So they just do random sampling so well that they're able to make those conclusions. Because if our sample's random enough that everyone has a chance to be selected, we can be rest assured that it is representative. For instance, Quinnipiac University selects phone numbers completely at random. So any chance of you could get an 18-year-old on their cell phone or a 65-year-old on their landline. I assume people still have landlines. I don't know. All right, observations versus experiments. So what we were talking about there, survey, like a political survey or asking people what they like for breakfast. Those are called observational studies. An observational study is a research study where we observe individuals and gather data, but we don't attempt to influence the responses. In an experiment, we deliberately change something or impose a condition and then measure the response. This change or condition, it's called an intervention, not to be confused with like the stuff you do with like people who like are addicted to drugs. That's a different kind of intervention. So intervention here is the change, the condition that we impose. It sounds a little like up in the, like a little weird right now, but I'll give you some examples. It'll start making sense in just a second. Experiments are often the only way to confirm some cause and effect relationship. I mean, we can study, okay, does breakfast improve performance at school? And we can do an observation, but maybe kids who have breakfast have more engaged parents or something like that. That's what's called confounding. We'll talk about that in a second. What we're able to do with a experiment with that intervention is we control everything as best we can, just so we can get the most accurate answer. All right, so let's talk about a couple things and think about whether or not they are observations or experiments. So what if we did a research study where we measured college students' typing speed? Well, that'd be an observation, right? We're not changing anything. We're just looking at how fast they can type on the computer. What about if we have students go through a computer course? We test them before the computer course, and then we test them after the computer course. And we see how their typing speed has improved. Well, in that case, that would be an experiment, right? The computer course would be the intervention. We have imposed a change on those students. So that would be an experiment. Well, what about measuring students' typing speed, just like we did the first time? Well, maybe the research environment, the study room that we're testing this, a portion of the participants don't have any music or anything at all sounds, and then a portion of the participants have just low, relaxing music playing in their experiment room. Well, in that case, that's also an experiment. Even if it says something minor as just playing a little light music, any intentional change to the study would make it an experiment. So keep that in mind. Even something as minor as, I don't know, if you put a scent into the air. Maybe we are testing to see if people are nicer to each other if we use lavender air freshener or something. Something like that. Even if it's super minor, that can still be an intervention. And if it's an intervention, it means it's an experiment. So we already talked about confounding a little bit, both back in like September, October, as well as just a couple minutes ago. But confounding. Confounding is where one variable is related to one or more variables that influence the response. So there's that old one that I used on y'all September. Think about the mayor who did a study and realized that as people eat more ice cream, homicides go up. Well, that's a perfect example of a confounding variable, because in that case, hot temperature. Whenever the heat increases, people eat more ice cream, and it's caused more murders. Or in this example on the bottom, when there's hot temperature, rate of ice cream goes up, and sunburns go up. If you didn't think about the confounding variable, you would think ice cream causes sunburns. This is also what we call a lurking variable, where in this case, the hot temperature is the lurking variable that influences the data that we weren't necessarily aware of. When doing research, we try to minimize confounding variables whenever we can, because the more confounding variables there are, the worse the data is, the more useless the data is. It's a waste of money at that point. It's a waste of time. Let's also talk about a little bit about some experimental design terminology. So you'll hear me say subjects or participants a lot. These are what we call people that participate in research. Of course, there are other types of research where people don't participate, or where there's animals. We won't be talking about that. We'll just be talking about people research. Well, there's also called treatments. Those are the experimental conditions. We also call them conditions, or like we just talked about, interventions. We also have factors. Those are the explanatory variables. Those are like the X in that case of, well, we'll get to it in just a second. It'll make a little bit more sense in a second. It's tough to explain. We also have levels. They are the different treatments. Oftentimes, if we have 3 different groups with 3 different treatments, we would say we have 3 different levels. And lastly, we have outcomes. Those are the measured variables that are used to compare the treatments. So you can think about right here, when we measure students' typing speed, while a portion of the participants have low music playing in their experiment room, the outcome would be their typing speed, and to see whether or not their speed had increased when there's music playing. Okay, so that's a lot, especially since I didn't give you a good example of what a factor is, so let's use an example. Let's talk about the Tennessee Star Study. This is one of the greatest educational research studies that we've ever carried out. So we wanted to see whether smaller classes in elementary school would benefit students' grades and chances to get into college. This is one of these where you'd think it would be good to do as an observational study, but there's a lot of confounding variables there, right? So first, schools with smaller class sizes tend to be in richer neighborhoods. Richer neighborhoods mean that those schools have more resources, because of course all the school funding comes from property taxes from the neighborhood. So if a school's in a richer neighborhood, that means it's got probably better teachers, better equipment, things like that. If you're dealing with richer neighborhoods, you're probably dealing with educated parents, you're probably dealing with more stable families, things like that. So it's very difficult to try to do that with a simple observational study. And so we can do it with an intervention here, and that's what they did. So the subjects, there were 6,385 kindergarten students. The factor in this case was class time, right? We want to see regular versus small classes. So the factor in that case would be what we're testing. In this case, there are 3 levels of the factor. And then the treatments. The first treatment was a regular class, 22 to 25 students with 1 teacher. The second was a regular class with 22 to 25 students, with one teacher as well as a teacher's aide. And the third is that there was a small class, 13 to 17 students, with one teacher. The study went on for about 4 years. They were teaching the kids in these environments, and they followed up years later. They found that the students in the smaller class size had better outcomes. What they were looking at was their standardized test scores. And they found the kids in the small class actually started to excel over the kids in the regular class. So we proved that small classes have a big effect on performance in school later on. So hopefully that clears all that up. Hopefully that makes it a little bit more sense. Yeah. So next, bias. So bias is defined as systematically favoring certain outcomes over others. Bias is a lot like confounding. It's really, it's the death knell to good research. It's terrible to research. Doing heavily biased research can be a complete waste of time. Types of bias include things like the placebo effect. You've probably heard of the placebo effect before. It's really big and it's really important. So make sure we understand this. So with the placebo effect, it's a psychological effect that we have. We feel better after getting a treatment, even if that treatment is fake. So if I had a headache and I wasn't aware of, let's say a pill that was a fake, usually it's a sugar pill, it's just sugar. And I take the pill and suddenly my headache goes away and I feel a little bit better. Well, it's because I did something about it. It's that mental feeling of, okay, I've done something, I feel better. The same thing you can also see in therapy. Oftentimes they take therapy, they look at the effectiveness of therapy by just comparing it to, having a conversation between the researcher and the subject. A very casual conversation where they kind of talk through issues they've been having and things like that, but they're not actually using any sort of therapy skills. And in that case, even talking, there's that benefit from there. Going to the doctor, too, can make you feel better. Even if the actual experience of being in the doctor may not be all that fun. But the actual feeling of receiving treatment can actually make you feel like you've gotten better. You can also have the opposite, too. Not nearly as important, just want to make sure to cover it. The nocebo, where you can have side effects from drugs that are completely random and not physically caused by anything. But that's just stupid, Mr. Brent, side thing. Ignore that. Next, we have what's called recall bias. That's differences in the accuracy of recall. This is really common when you have studies that involve people keeping track of a behavior, like how much they smoke, how much they eat. Think about it yourself. Think about what you've eaten the last 3 days. Can you say that out loud? I know I couldn't. I struggle with remembering stuff like that. So if you said, hey, what did you eat in the last 3 days? I could probably give an effort at given some time, but it's going to be pretty difficult for me to remember all of that stuff. So that's an example of recall bias. There's a wide variety of other biases as well. How people are put into studies, things like that. But placebo effect is the big one that I want to make sure y'all get here. Recall bias is still important, but not as. All right. So next up, treatment and control groups. So participants, when we're doing a research study, are often divided into treatment and control groups. Obviously, treatment groups receive the treatment, and control groups receive a very similar experience to the other group, only no treatment. So what we're able to do here is we're able to compare, well, what does this treatment do for the people that not doing it won't do? So in some cases, we have a placebo or a sham treatment. Let's say I'm testing my new headache medicine. Maybe I want a placebo-controlled study on it. I'll take a group of participants, split them in half. The treatment group will be my drug, and then the control group would be a sugar pill. That way you still have the placebo effect, but we're controlling for it, because the placebo effect is going to work for both groups, both the treatment group and the control group. They're both receiving treatment, so they're both going to feel better. So that's how we control for that. So we also have treatment as usual. This is oftentimes where the control group is the commonly accepted treatment. It's helpful when we want to see if our treatment's better than usual or that it's kind of unethical to give a placebo. I probably shouldn't have used the Tennessee Star study because that's a good example of both of them. So if we, for instance, wanted to look at, okay, is this better than, are small classes better than normal classes? Well, if we wanted to, we could say, well, what about larger classes? Are they worse? But in that case, there's some questions about ethics there because you're actually giving people something that you think might be worse than what they're already getting, so it's a little awkward. Especially in some cases where, let's say, you're dealing with people who have cancer. You're testing a cancer drug. We still want to make sure that these people are getting treatment. So, in the control group, we're going to give people their treatment as usual. And oftentimes, in the experimental group, once they are done, or the treatment group, when they are done with the experimental medication, they'll also go to treatment as usual as well. Because at the end of the day, they still have cancer and they still need treatment. But we also want to make sure that we're testing this drug for efficacy. Also, randomization. Randomization can be important. So this is when participants are randomly assigned to each of the groups, either treatment or control group. If the groups are substantially different, for instance, sicker people get put in the treatment group and more well people get put in the control group, that's when you get bias, right? In that case, you've got a systematic difference between your groups there. Researchers sometimes set up non-randomized studies. We will talk about that next week. I should have edited that. We're also going to talk a little bit about it right now. But the most common thing is what you call simple randomization, where you take your participants, and each participant has an even chance of being in each of the groups, either treatment or control. You just kind of break them off. So there are some difficulties here that we can talk about that are pretty interesting. First, experimenter bias. Experimenter bias is when researchers are aware of the treatment and control groups. And in that case, they might actually treat them differently. They might, and this isn't like, the researcher saying, hey, you're in the treatment group. You're good. Don't worry about it. Researchers are professionals. They know that that's fine. But even in subconscious ways, they can act differently. So this is why researchers do what are called double-blind studies. Most of the time, we have what are called single-blind studies, where participants are not aware of whether or not they're in the treatment or control group. When you think about it too, if participants are aware they're in the treatment group, they might actually expect to get better, and they might actually do get better than if they're in the control group. So that's why we blind them to whether or not they're in those groups. And to avoid the experimenter bias, we also blind the experimenters as well, so that they don't even know which medication or which treatment this person's getting. Double-blind controlled trials are pretty much the gold standard of drug research, medication research. So that's typically what they'll do. Another big difficulty here is that the placebos are ineffective or unrealistic. Sometimes it's really difficult to create a realistic placebo. For instance, if we study how blueberries improve heart health, well, how do we create a placebo blueberry? There's an example in the textbook of this exact thing, except it was bone health. The control group participants were receiving grapes. Well, at that point, it's fairly obvious that you're receiving something different from somebody else. And some of the participants knew that blueberries were supposed to help with bone health, so they already knew that they were part of the control group in that case. Also, lack of realism. It's really difficult to study certain unique behaviors. For instance, how do we study the effects of layoffs on workers if our subjects are all college kids? Do we do a simulation? How effective or realistic would that response be? We've gotten pretty good at figuring out ways to get emotions out of people, whether they're reading a emotionally difficult story or something like that. But it'll never compare to how people behave when they're angry, or how people behaved when they were laid off from their job, or things like that. At the end of the day, if we don't actually have the real people, then there's a question about realism there. And then lastly, generalizability. We've talked a lot about generalizability already. Y'all already know most research is being done in Western educated countries, and often on college students as subjects. And how does that compare to the average person, let's say a 65-year-old in Wyoming? Did the research we did on 18-year-old college students in Florida, is that going to be relevant to people in their 60s in Wyoming, or people in China, or people in India, things like that? There's not a lot of good, easy answers there, but it's just keeping those questions started in your head, giving some chance to think about those. The other examples of non-randomized design, the first one is matched pair design. Any sort of accurately and systematically assigning participants in groups tends to be superior to just randomly assigning them. The downside to it is that it takes a lot of work. And oftentimes you can miss obvious things where you split people off. So you can control for, gender, you can control for race, you can control for age, all of that. But at the end of the day, sometimes it's just easier to just split people up randomly. But the matched pair design, what it does, it can only be used with one treatment and one control group. What you do is you pair up participants. If you think it's relevant, let's say age and sex is relevant. So I'm doing a research study. I'm going to take a pair of 18-year-old white men, send one to the treatment group, and randomly assign one to the treatment group and one to the control group. And I'm going to take a pair of 18-year-old women. I'm going to randomly assign one to the treatment group and one to the control group. I'm going to take a pair of black men in their 60s. I'm going to assign one to the treatment group and one to or randomly assign one to the treatment group, one to the control group. That way you're able to control it to some degree, but you also have that randomness, so it reduces bias there. I know it's a little bit difficult to understand. I've got a little visual example here. So you see the participants up top. So the first step, we match each participant with their closest partner. And in the second step, one participant from each pair gets randomly assigned, and the other is automatically assigned to the other group. So you can see how they've all split off there. The next is block design. So what a block is, it's a group of subjects that are known before the experiment to be similar in some way that's expected to affect the response to the treatment. What a block design allows you to do is take those blocks, separate them, and then randomly assign them to each group. And that way you get the best of both worlds. That block is still evenly distributed between the two groups, but there's also still random assignment. So ignore the no blocking one on the left. So look at the one on the right. So we take everybody that's agreed to participate. Let's say we've got a cancer drug that we know affects men and women differently. Let's say we put all the men in block 1 and all the women in block 2. We take all the men and we randomly divide them between treatment and control group. And then we take all the women and randomly divide them between treatment and control group. That way, we are able to minimize that variation in those groups. We now have half women in treatment and half men in treatment, and half women in control and half men in control. So we're able to make sure that we have that variation so that we don't end up with simple random assignment where we might accidentally have 90% men in the treatment group, 90% women in the control group, which, due to sheer random assignment, might happen. So that helps us out there. All right, so that's all for now. I wanted to start off a little slow so we can ease into this. We've got a lot to cover, so we'll be doing more as we keep going. That was just 2 sections. We'll be doing 2 more next week, and then I'll start trying to do maybe 3 sections per. If we get to a point where you're overwhelmed, please email me. It's kind of in a weird place. I can't see if y'all get overwhelmed, so please, please, please tell me. My email is always open. You can always send me something on Google Classroom. Seriously, just let me know, and I'll work with you. I know it's a little weird, the whole remote thing, but we'll figure it out together. All right. Well, you'll have the quiz to do. The materials should be up. You can print the PowerPoint materials and use that to do the quiz. If you have any questions about the quiz, feel free and email me. Yeah. Otherwise, I'll talk to y'all next week.